Hello and welcome to today's lesson on thermal energy. Today we will learn what thermal energy is and how it is generated by the movement of particles within a substance. We will also identify and explain various real-life examples of thermal energy in everyday activities and objects, and understand the theoretical concept of absolute zero and its significance in scientific research. So far, we've looked at various forms of energy, such as kinetic and nuclear energy, and how energy can transform from one form to another. Expanding on this understanding, we will explore another type of energy, thermal energy. By understanding how thermal energy works, we unlock a greater comprehension of how energy transfers and transforms, impacting everything from everyday objects to advanced scientific applications. Let's dive deeper into what thermal energy is and how it works. Imagine that you are in a crowded room full of people. When everyone is standing still, the room is relatively cool. But as soon as people start moving around, walking, dancing, or even just fidgeting, the room begins to heat up due to the energy they generate by moving. The more people move, the warmer the room gets. This is similar to how molecules work in generating thermal energy. Every object or substance is made up of atoms and molecules, and these molecules are constantly moving. In any material, the particles, atoms and molecules are constantly moving. Even in a solid, where the particles are tightly packed, they vibrate in place. In liquids and gases, the particles move more freely and rapidly. This movement generates energy, which we call thermal energy. Thermal energy is defined as the energy possessed by an object due to the motion of its molecules. Thermal energy is a form of kinetic energy that manifests through the movement and vibration of particles. The speed at which these molecules move determines the amount of thermal energy. When these particles move faster, they generate more thermal energy, which we feel as heat. Conversely, when particles move slower, the object is cooler because less thermal energy is produced. When we heat a substance, we increase the movement of its particles, thereby increasing its thermal energy. Thermal energy can be transferred from one object to another. When a hot object comes into contact with a cooler one, the faster-moving particles in the hot object transfer some of their energy to the slower-moving particles in the cooler object, making it warmer. Let us now examine how everyday objects and activities provide tangible examples of thermal energy in action. When you boil water for tea, the heat energy is transferred to the water molecules, causing them to move faster. This increased movement of molecules causes the temperature to rise and eventually causes boiling. The boiling water, therefore, has a lot of thermal energy. The refrigerator's compressor and coolant system work to transfer heat away from the food. Thermal energy is removed from the food items inside, causing the temperature of these items to drop. This slows down the movement of molecules in the food, preserving it for longer periods. Your own body temperature is a result of thermal energy. The cells and molecules in your body generate heat through chemical reactions and movement, keeping you warm. Before we finish, let us explore a fascinating concept called absolute zero. Absolute zero is the theoretical temperature at which molecules stop moving entirely. At this point, the thermal energy of the substance is at its minimum because there is no movement of molecules. Absolute zero is minus 273.15 degrees C or 0 Kelvin, and it represents the coldest possible temperature anything can reach. Scientists and researchers are highly interested in cooling materials to temperatures near absolute zero. At these extremely low temperatures, materials can exhibit unusual properties such as superconductivity, where electrical resistance drops to zero, and superfluidity, flow without friction, which have various cutting-edge applications in areas like quantum computing and advanced medical technologies. Understanding thermal energy is crucial because it helps us comprehend how and why objects change temperature, which has practical implications in everyday life and advanced technologies. Whether it's boiling a pot of water or exploring the depths of absolute zero, thermal energy plays a fundamental role in the physical world around us. In today's lesson, we delved into the concept of thermal energy and its significance within the broader context of energy. We defined thermal energy as the energy derived from the movement of molecules within an object. We linked thermal energy to molecule movement and to temperature, understanding that the faster molecules move, the hotter the object becomes due to increased thermal energy, and conversely, that the slower the molecules move, the cooler the object becomes as it possesses less thermal energy. We then explored real-life examples such as boiling water, refrigerators, and body temperature to see thermal energy in action and appreciate its presence in everyday scenarios. Finally, we briefly discussed the fascinating concept of absolute zero, where molecular motion ceases entirely. Understanding thermal energy is crucial for comprehending how energy transfer occurs in various processes, which is a fundamental aspect of physics. Mastery of this concept lays the groundwork for further exploration into energy transformations and the practical applications of thermal energy in different fields.